Hey everyone, welcome to my channel. Today I am gonna be talking about the state of Compose. These are topic that I presented in DevFest Goa and DevFest Belgaum in 2022, and unfortunately none of them were recorded. So I thought of recording it myself and posting it in my channel. Please do feel free to share feedback and any suggestions you have. I would try to record new contents like this and post it regularly in my channel. So please subscribe and turn the bell notification on. So without any further delay, let's get started. So here's a little bit of my introduction. I have kept 2 slides for my introduction and a little bit of self-promotion. So yeah, I am an Android dev. I have been in industry for over a decade now. I am a GD or Google Developer Expert for Kotlin. I am an author. I wrote books. I speak at events, and I am an overall community person. So I attend and speak at and organize events. I am a consultant. So currently I am freelancing or consulting with multiple startups. So if you are a startup and if you need help in anything Android or Kotlin related, please feel free to reach out to me. Here are my Twitter and Mastodon handles and my website. Please do check them out and follow me if you would like. Here are some companies I worked with. You can see them on screen, so I won't repeat them and waste time. Our topic today, the state of Jetpack Compose, right? Or the state of Compose. Here by Compose I mean Jetpack Compose, which is Android's latest UI toolkit to write declarative UI. You can read more of that by going to Jetpack Compose website. Just go to android.dev and search Jetpack Compose and you will get it. So in Jetpack Compose we write UI in Kotlin. I will show you in next slide. But let's get to the first question I get whenever talking about Jetpack Compose, right? Is Compose ready for production? Short answer would be yes. And so if you are building, even if you have a complex UI, right, Jetpack Compose is production ready. The current stable version release is 1.3.2. When I last presented this topic, it might be a little 1.3.3 or 1.4 right now. I am not exactly sure. I have to check that, but yeah, it has been production ready for over a year now. Although, like any new framework in market, Compose has or address a few of the edge case scenarios. For example, infinite scrolling view pager, right? Or rather a view pager with pagination. That might be a bit difficult to implement currently with Compose. But yeah, that's an edge case, or that's edge case scenario. Right. So yeah, overall for regular day-to-day use cases, even for complex cases, I would say Compose is production ready, and you can see a lot of apps are already using Compose, right? Some of them are listed here. You can read more at developer.android.com or the link I showed here, right? You can go there and check them out in details. Yeah, they have testimonials as well. So yeah, I was talking about how Compose code looks like. Here's how it looks like. I have used here constraint layout. So in Compose you don't really have to use constraint layout. You can achieve the same by using columns and rows. The benefit of constraint layout in XML was that it used to flatten the hierarchy. That means before constraint layout in XML we used to use relative layout, linear layout, frame layout, and combine all those, and there was a big hierarchy, right? That used to affect memory and performance of UI a lot. So with constraint layout, that problem got solved, and you could easily put all of your UI inside a single layout or view group. With Compose, that benefit is not really there, since Compose is anywhere flattened. So you can use rows, columns, but what I believe with constraint layout is that it looks a bit more professional. The code looks a bit more professional, and it gives you a lot of flexibilities as well, right? So that's why I generally prefer constraint layout. Now let's come to our main topic of discussion, the state. So what is state? I believe UI is the exact representation of your state, right? So here we have a data class that is represented in our UI. Now there can be two kind of states, right? One is UI element state. For example, the state of a button, or say here the state of the progress bar that I was showing, or state of the lottie animation I was showing. So all of these has individual states, right? And then there is something called screen state. So here whatever you see that we are searching something is loading, and some list is shown. When you click list item detail is shown. All of these are screen state. So whenever loading happens, that's a screen state, right? Here I have a single screen. It's not divided into multiple screens in this example. So whether detail is showing or not, or whether list is showing or not, it's maintained in a single state. But you can have screen based, so you should divide screens based on use case, right? So generally in my use case, I didn't have any complex details, so only same details is shown in detail and in list. In detail it's just a little bit bigger, in list it's just a bit smaller. So that's why I basically kept it in a single screen. But I would recommend you divide it or separating out list and details, and then you can implement screen states for each of their own, right? Now here you can see how I am basically observing to that state, right? So I am here, my view model is actually emitting live data, and here I am observing live data from my composable function. Now that is not the only way to observe state in composable. There are a lot of ways. I would talk about them in detail later, but let's move on, and let's talk about UI element state, or how to actually observe the state changes in general, right? So here is something that you will see pretty often in a composable code base. So here it's basically observing and maintaining UI element state that I talked about. For example, a button is enabled or not, exactly what that's doing here. So we are using mutable state of and remember, right? Now what each of these do, I will talk in details. So let's start with mutable state of. So what does mutable state of do? Right, so it basically creates a state. So there are two ways to create a state, right? With state of functions, mutable state of and state of. So when you create a state with state of, that is not mutable or that is not editable. So that's basically when you observe something from view data, live data, right? So that's basically created as an unmutable state by the composable. So you can't edit that state from within the composable. But here what we want is that we want to enable or disable button from within the composable. That's why we are using mutable state of. So it creates a state object. Mutable state of creates a state objects that is editable or mutable. Now let's come to remember. So what happens if you just put mutable state of in button enabled, right? Button enabled mutable state or data type equals to mutable state of. What happens then? So basically composable is a function, right? Like we saw in previous slide. So whenever some state change happens, a composable recomposes, and whenever that recomposition happens, then what happens is that if you declare your variable mutable state of at the beginning, then it would be reset again, and that can lead to infinite recomposition. I will talk about that more in later, but yeah, for now remember to use remember whenever you are creating a state with mutable state of. Now that doesn't mean that you should use remember every time you create a state, right? So here are a few examples where remember is not required. So whenever you have a state holder, right? So whenever your state is created by something outside of your composable function, for example, here state is created by view model. So I am using mutable state of in view model only. So that state is created, and then that state is exposed to my composable function, right? Here you can see that, and here I was creating with live data, right? And then observing that live state as observing that live data as state here in composable function. So in both cases, even if this my compose or block gets decomposed or called again, what would happen? It would get state from this view model.state, or here it would get state from the latest live data value, right? So that's what we want anyway, right? It's it won't break your code. So that's why remember is not required, because you are getting the state from a state holder that is outside of your composable. But whenever you are getting a state from within your composable, for example here loading state, or earlier what I shown button state, now it doesn't mean that your UI state has to be inside or UI state always have to use remember. It doesn't mean that. What it means is that whenever your composable is creating some state and maintaining it, probably it is delegating the state to some other composable and it is working as a state holder for that other composable, right? But still it is creating its state and it is maintaining it, right? So in that case you need to use remember. Since it is also a composable function, it can or it will get recomposed, so it's better to use remember to create the state. Now also you don't actually need to worry much about that. Whenever you are using mutable state of inside a composable function, the compiler itself will show you with a warning that hey, you need to use remember whenever you are using mutable state of within a composable function. Now I talked a lot about state hoisting, right? So let's talk what state hoisting is. So state hoisting is basically a fancy term, I would say, to explain the state holder and state passing, right? So who should hold the state and in which scenario, and how should you pass the state? So here my state was basically my view model is the state holder, and and then the live data is passed to composable, right? So view model is working as a state holder, and then we are creating the states based on that. Similarly, here you can see that I am creating a state for each splash playing, right? And I am passing that state to splash screen. So as view model is hoisting the state for movie screen is hoisting the state for splash playing. And here in the splash I am basically observing that state, and I am also updating it. Now it could have been done callback as well. So whenever that callback value is reached, you can pass update. Instead of passing update via state, you could pass update via a callback and then update the state there. But since whether it's playing or not, it's directly dependent on this Lottie animation state. It doesn't have any other complex logic to it, so we are modifying the state here. And yeah, when to hoist your state, right? So basically whenever you should rely on callbacks, and that is called hoisting your state. So instead of passing state as a mutable state as a primary, you should pass your state, and you should apply callbacks. For example, what we are doing here with the search screen. Yeah, whenever you have your composable that is directly like the state is directly dependent on that in a composable, right, that you are calling, and there is no custom way to it. So then you should basically pass your mutable state. It some example would be, for example, how we use the editable text field, right, or text field in general in Compose. So you create a state, and then you pass that state to text field, and then whenever user types something, that state is updated. So that's how you know that user typed something, and you always have the latest content from the text field, right? So why Compose team did that? So earlier what used to happen with XML is that edit text would hold its own state, and you would get the updates by callback. Now here Compose team for text field has delegated the management of state to whoever is to the developers, right? So our function is responsible for managing the state for the edit text field, and pass our text field state to that, and it will be updated. And you can go to this link. They recently updated this link, and it contains very good recommendations on state hoisting and state management in general, so you should definitely check it out. And here's what they said on state hoisting. What is state hoisting? Now let's create a form, right? So I am typing something here, right? And when I'm done, a new text field comes. Basically, you can think of it as list of items, right? For example, in Dunzo, when you order something from store, right, you type something like that. And you are building a similar app, or you are building a to-do list app, or you are building a recipe app where you need to list items, right? Then you would need this kind of screen. So let's talk about how to implement this. So here I have a form screen, and I have something called add item query, which is nothing but a string state, right? Then I have a column where I am creating my form, which would have how I am adding it. I have a column, and I am calling the my form object. So here you saw the form screen, and here the actual my form function, and here I am passing the state to it. This state is viewModel.state, and so this state is not exactly editable from my form, but yeah, I am on add item. I am updating the query. So on add item is a callback, and whenever user types something on add item, that query will be updated here, and based on that we will do something that we'll talk about. And on update item, I am just calling a viewModel.update item, right? Now whether to or not to allow the user add item, right? So here I am keeping it as always true, but sometimes you say you have a limit of items, right? You don't want user to add more than say 5 items. So in that case, you can put some logic here. Now here's the my form object. Here I have a lazy column and a list of items that is basically passed from the state. And for list of items, I am calling items indexed, since I need the position. So I am calling items indexed, sorry. And based on that, I am displaying that item, right? And now let's talk about how that item query works. So I am using launched effect here. So whenever add item query is changed, right, as you can see, or as if you can remember, whenever add item is modified, or whenever user types something on add item query is modified through a callback, and then we are observing this from here, launched effect. And here if it is blank, it would not do anything, but if it has something, we are dealing 500 second. Why? So that it works as a debounce effect, right? So if user is typing something, so for each typing it won't be called, it would have a 500 milliseconds delay before calling viewModel.add item. And so once viewModel adds the item, our list of items will be updated. Now that item come as a list instead. Now I talked about infinite recomposition, or recursive recomposition. Let's dive deeper, right? So how can that happen? So here I have a button, and here's what I actually want to build. If you click on recompose, count should increase, right? A very straightforward implementation. So here I have a column, and here I have a button and a text and a counter, right? So whenever so at first we are calling viewModel.recompose, and then on each button click we are calling viewModel.recompose. And here we have recompose state at viewModel.state, and we are basically recomposing on we are basically whenever state is updated, we would recompose and we would update the count. Now remember here, we recompose state equals to viewModel state, and we are calling viewModel.recompose because initially we want the count to start from 1. So initially counts value is 0. As you can see in viewModel, counts value is 0. So whenever spin is displayed, we want to start the count from 1. So that's why we are calling viewModel.recompose here. And on each button click, we are again recomposing, calling recompose, which will update the state and your compose will be recomposed, right? So here actual, if in an actual implementation you would call viewModel.update count, but here why I renamed recompose is that to let you know that whenever this state is updated, the compose level will be recomposed. Now I would show you the output on what exactly it achieves, but before that I want you to comment what you think would happen if we run this. So I am giving you some time to think what would happen if we run this, and please comment below. Okay, now let's see what happens. We haven't even clicked recompose. It's recomposing infinitely. Why? Because of this, we are calling viewModel.recompose outside, right? So whenever you do that, so every time that recomposition happens, it finds a function again, viewModel.recompose. It triggers the state change again, and again recomposition happens. So it becomes infinite or recursive recomposition. Now how to avoid that? Simple. Use a launched effect. Use a launched effect and put the key as unit, so it won't be called again. So whenever you want something to call something once and never again, you can put the key as unit, and then you can call viewModel.recompose within that launched effect. So only once it would be called. For each recomposition, this would be ignored. Now if you want to observe on something and call recomposition multiple times based, or call some viewModel function multiple times based on something is changed, then you can do what we did with add item query. So there the key was add item query, and whenever add item query was changed, viewModel.add item was called, right? So you can achieve that with launched effect. Now if you run it now, it would be perfect. That's all for my today's presentation, and here are some resources you can find. I would highly recommend them, and do check out my website as well. You can subscribe to my website. You can follow me on Twitter, and thanks for being with me so far. Please share your suggestions and feedbacks in comment or directly with me if you via Twitter DM. So yeah, that's all. Thank you.